All right, so we're doing more writing equations of lines, continuing on that handout. We're looking at special situations still, but we just finished horizontal and vertical. Now we're going to look at special situations where the lines are parallel or perpendicular. Parallel or perpendicular. Okay, so just some things you need to know. Parallel lines, they're lines that look like railroad tracks, okay? All right, so they never intersect. Okay, their M's, their slopes are the same, and their y-intercepts, their B's, are different. So that's what it takes to be parallel. Slopes need to be the same with the y-intercepts different. Now they might be oriented that way, or they might be horizontal, or they might have an orientation this way, but the idea is if you kept going, they're never going to intersect. They have the same space between them, and that's because their slopes are the same, okay? And then the other special case you need to know about is perpendicular lines. Okay, perpendicular lines, sometimes we say their slopes are negative reciprocals of one another. Okay, so what that means is, let me just give you some examples to help you see. So here's one slope, here's another slope. Okay, if the lines are perpendicular and this one has a slope of 3, that one's going to be opposite and the reciprocal of 3. Okay, all right. Let's say the first line had a slope of 2/5. The other one would be flipped over and opposite. All right, now what if the first one was negative 1/4? The other one would be flipped over and opposite, so it would be positive, and you would simplify that to be 4. So 3 and negative 1/3, 2/5 and negative 5/2, negative 1/4 and positive 4. A special kind of weird one is 1. If you flipped it, it would be 1/1, took its opposite, you'd wind up with negative 1. Okay, and if it started out negative 1 and you did its reciprocal and then took its opposite, you'd wind up with positive 1. Notice though that 3 and negative 3 are not perpendicular. See, if you had a 3, when you flipped it, you get a 1/3. All right, and then one more you need to know is if you start out with a 0 slope, to be perpendicular, the other one has to be undefined, because it's the horizontal and the vertical would give you perpendicular lines. So perpendicular lines, they would look like this. If one had a slope of 3, the other one would have to be a slope of 1/3. It'd have to be flatter, okay? So let me just do it in general. So in general, if you had one line, the other one would have to form a right angle to it. It could be in various orientations, but it would have to look like that eventually with 90-degree angle there. Okay, so that's just the information about the slope of parallel and perpendicular lines. All right, but what if we needed to write the equation of a line that passed through a point, but then it had to be perpendicular to y equals 1/2 x plus 14. Okay, this is number 11. And then when we finish that, we'll do one that involves parallel. All right, so your thought process should be, okay, I'm trying to write the equation of the line. I know I ultimately want it in slope-intercept form, but I've been using this point-slope formula to get there. I have a point, so it seems like this is going to be where I get my x1, y1, but I need to be able to get my slope of the line I'm trying to write the equation for, okay? This is what you're going to use to get your slope. Use to get slope of your line, okay? So it's you really got to keep your wits about you. So the line you're given is y equal 1/2 x plus 14. It is in slope-intercept form, so we know the slope of that line is 1/2, right? That's not the slope of my line, though. The line perpendicular to that would have slopes that are opposite reciprocals. So if you started with 1/2, you'd have to flip it and make it opposite, which means your line would have to have a slope of -2. Okay? This is slope of the line we want. Now here's what's hard for people to do. That's all we're getting out of this perpendicular to part is the slope of our line, okay? So we know the slope of our line now is -2, and remember we knew already that it passed through the point, -5, -8. So we're ready to put that information together. So we plug in the -8, plug in the slope of -2, put in the -5 where the x1 is. Y minus -8 is y plus 8. X minus -5 would be x plus 5. So now I'm just cleaning it up and getting it into slope-intercept form. I'm going to distribute. Okay. And then I'm going to move the 8 out of the way. And I have my answer. Y equals -2x minus 18. Okay, so let's recap. You always got to go back and kind of think about it a little bit. So this part over here where we knew our line was perpendicular to y equals 1/2 x plus 14, we use that to get slope. You use this part right here to get slope. So once we go through all this thought process, we determine our slope is -2, then we're done with this. We bring over the fact the slope of our line is -2, put it together with the fact our line has to pass through the point -5/8, and we're back to that earlier question we had. This is now just like number 6. You see that? Okay. Notice the 14 had nothing to do with our new line. All right, let's do the number 12. Number 12 deals with parallel, okay? So number 12 says, write the equation of the line that passes through the point -3, -5, and is parallel to this line, 6x plus 5y equals -63. Parallel to means same slope. Okay, that's what you should think. Up here where you saw perpendicular, when you saw that, you should be thinking negative reciprocals. Slopes are negative reciprocals, okay? All right, now here's the deal. So we have a point that we could plug in. We just don't have our slope. So you should be thinking, okay, I need slope of my line. I'm going to get it from here, this information, okay? But this one, the equation was not written in a good form for me to just pull the slope from that equation. So I'm going to be thinking about how if I could rearrange it and get it so y was on a side by itself, I could identify the slope. So this is 5y equals -6x minus 63. I'm going to divide by 5 everywhere. I'm going to wind up with y equaling -6/5 x minus 63/5. Okay. All that work so that I can figure out the slope I need to use. So the slope of this line was -6/5. Your thought process should be my line is parallel, so it's the same. So now you take the fact you know your line has a slope of -6/5, but your line has to pass through the point -3, -5. So you're done with all this information. You're done with that. You're now kind of like at a new problem that's just like number 6 again. So you're going to start over, right? Go find that point slope formula, write it down, plug in your slope, plug in your x1, plug in your y1. Make sure your x goes with your x. Make sure your y coordinate's with your y coordinate. So that's y plus 5, negative 6 fifths, x plus 3. Okay. Oh, this one's not going to be very nice. Distribute. That's negative 6 fifths x minus 18 fifths. Just do that on your calculator. Just do negative 6 fifths times 3. Okay. I need y by itself, so I need to subtract 5. When I do, what I'm going to type in on my calculator is negative 18 fifths minus 5. Okay, when you do that, you're going to get, let me think, I have to do it by hand here, so that would be 25 fifths. So negative 18 fifths minus 25 fifths, that would be minus 30 minus 43. So don't forget the x, and then that would be minus 43 fifths. And they wanted it in slope-intercept form, so you'll be done at that point, okay? So with parallel and perpendicular, you have to use the fact or remember that with parallel lines, if they're parallel, slopes are the same as what you're given. If they want you to write a line that's perpendicular to some line, slopes are opposites, opposite and reciprocals. Opposite, or I guess let's just be consistent. I think I said earlier, negative reciprocals. So flipped over and opposite. Okay. All right, so let me go ahead and